Okay, guys, today we're going to be talking about elements and compounds. Please put your first and last name on the top of your Cornell note sheet. Put today's date. The topic is elements and compounds, and of course, our subject is science. Okay, what is an element? Please put the word element on the left side of your Cornell notes, or you can even write, what is an element? An element is a pure substance found in nature. They are represented by chemical symbols on the periodic table. And they make up all the matter that is on Earth. You have a periodic table in your textbook on page 687. So you'll want to get out your periodic table. You can look at the one in your textbook, or you can look at the one that was given to you. Okay, so take a look at your periodic table of elements. Guys, that is a list of every single element that exists on Earth. Okay, one of the reasons why gold is so valuable is because it cannot be made by man. Not real gold. All the gold that exists here on Earth is already here. And we've either found it, or it's up to us to find what is left here on Earth that already has not been found. Okay? This is one of the reasons why we recycle metals, like aluminum. Okay? Because all the aluminum that exists on Earth is here. Okay? We cannot make any more. So an element is a pure substance. It's found in nature. It cannot be man-made, most of them. There are a few exceptions for some of the new ones that are at the bottom of your periodic table. Okay, but take a look at the chemical symbols. See, this is where your academic vocabulary is really coming in handy. The chemical symbol. Okay, so notice the chemical symbol for carbon is capital C. What is the chemical symbol for hydrogen? What is the chemical symbol for hydrogen? Take a look. It's capital H. What is the chemical symbol for helium? Capital H, lowercase e. Take a look at your periodic table. Are there some of those elements that are weird? That have weird chemical symbols? Which ones have weird chemical symbols? Gold. Okay? Gold is AU. You would think it would be capital G, right? But it's not. Do you know why? Because the Latin name for gold starts with AU. Okay? Same thing with potassium. Take a look at potassium. You would think it'd be a capital P. It's not. Its chemical symbol is a K. Okay? And if you were to get on Google and look up the Latin word for potassium, you would notice that it starts with a K. Okay? So what you need to know for this unit is that every single element is represented by a chemical symbol on the periodic table. When we use those chemical symbols, we're shortening that name. Okay? So carbon is a what? Capital C. Okay? Remember that elements make up all the matter that is on the Earth. Okay, so if you've ever wondered what things are made of, they're made of either one element or combinations of elements. We're going to talk about what that means here in a minute. Okay, the periodic table is a lot like a grocery store. Okay, you go to the grocery store and you get pasta and sauce and meat, and you go home and you heat it up and you make spaghetti. Okay, the periodic table is very similar. Okay, you take a little bit of this, you take a little bit of that, and you can make something completely new. Okay, for example, you take a little sodium, you take a little chlorine, you chemically bond them together, and now all of a sudden you have table salt, or sodium chloride, NaCl. And we'll talk about those here in a minute. Okay, let's look at the periodic table. Let's take some notes of the periodic table now that you've kind of looked at it a little bit. The periodic table is a list of the Earth's elements, and it's grouped by their characteristics. And we'll talk about some of those characteristics as the unit progresses. The periodic table was developed by a gentleman by the name of Dmitri Mendeleev. And in 1869, he put together the periodic table. He organized all of these elements on the periodic table. And they are not just placed there at random. Okay, there is actually a lot of ways that they are organized, and we will talk about those. Please know that it is constantly being updated. Okay, the version of the periodic table in your textbook is from like 2000. Okay, the version of the periodic table that I gave you, I think is probably about 6 or 7 years old. Okay, so they're just constantly updating them. It's okay if you use older versions of the periodic table, though, because all the really important elements are the same. They stay the same place. Okay. The new elements that are recently discovered, they're very heavy metals, and they're not used frequently. Okay. So for your purposes, for 8th grade science purposes, it's okay to use a little bit older of a version of the periodic table, because we're not doing anything with, numbers 101 or, 102. Okay. A big part of 8th grade science is for you to know the characteristics of metals, nonmetals, and metalloids. After we take Cornell Notes today, you are actually going to label the metals, the nonmetals, and the metalloids on your periodic table. On your periodic table, for the activity that we do at the end of class, your metals are going to be in blue, okay? And they're strong, they're solid, they're good conductors of heat and electricity. They're shiny. They're malleable and ductile, which means that they can be rolled out into thin, flat sheets and then also pulled apart like string cheese. Okay, so those are metals. And the majority of elements on the periodic table are metals. Okay, I'll say that again. The majority of elements on the periodic table are metals. Your skin is made of metals. Okay? Cow skin is made of metals, which is one of the reasons why when you go sit on leather seats in a car on a hot day, it conducts heat. Okay, and it will burn you through conduction. Okay, because skin is made of metals. Let's talk about nonmetals. Okay, the second most common elements on the periodic table are going to be your nonmetals. They are the exact opposite of metals. They are weak. Many are gases. They are poor conductors of heat and electricity. They are dull. Basically, they are the exact opposite of metals. So please make sure you're writing these. Okay, and then lastly, the third type of elements on the periodic table are called metalloids. There's only 7 of them, and they're really strange. They're weird. They are a combination of metals and nonmetals. Oops, sorry. There we go. Okay, so what that should say down there at the bottom is that metalloids have properties of both metals and nonmetals. I am so sorry about that last bullet point, guys. It should say that metalloids have properties of both metals and nonmetals. So each one of those individually are very unique, and you would just have to look at their unique properties, but overall you just need to know that they are metalloids, and we will label those at the end of this slideshow. Okay, can I move forward? Take a look up here. What is the most recognizable element that you see on these wrappers? What is it? If you said gold, you are correct. Okay? I know, I had to keep things interesting for you, right? Gold is classified as a metal on the periodic table, and its chemical symbol is AU. Okay, not capital G, but AU. And notice how it's written. It's written capitalized A, lowercase u. Okay, and we're going to talk about that in the next slide, how those chemical symbols are written. Okay, so please put the word chemical symbol to the left because that's your main idea for this slide. A chemical symbol is a letter or letters that identify an element. Okay, and it's really important that you recognize how they are written and that when you're writing them properly, and that when you're reading them properly. And the only way to read them properly is to know how they are written. So here we go. If there is one letter in the chemical symbol, like oxygen or carbon, it is capitalized. That letter is capitalized. So the chemical symbol for oxygen is capital O. If you write it as a lowercase o, it's wrong. Okay? The symbol for oxygen is a capital O. The symbol for carbon is a capital C. Now take a look at the chemical symbols that have two letters. There are some on your periodic table that have two or more. Okay, but for the sake of this, let's just take a look up here at the chemical symbols that are up here on the slide. Silicon, capital S, lowercase I. Sodium, capital N, lowercase a. It is very, very important that you know that the element, if it has two or more letters, the first is capitalized and the second is lowercase. Okay, does that make sense? Okay, take a look at your periodic table, okay, and identify some of the letters that have two identify some of the chemical symbols that have two or more letters. And notice that they're all written the same. Okay, that first letter is capitalized, the second letter is lowercase. Okay, now take a look at your chemical symbols on your periodic table that just only have one letter. Okay, notice that they're always all capitalized. When we start to count atoms and elements, it's going to be really important that you follow this rule. Otherwise, you're going to be counting them wrong. Okay, moving along. Please put a star by this information on your Cornell notes. You will be tested over this information. This slide will help you answer 2 of the questions that are going to be on your unit test. What I'm hoping that you get from the slide is for you to understand that what solid earth, what oceans, what the atmosphere, and what living matter is made of. So solid earth, literally soil, okay? Solid earth is made of silicon and oxygen. Solid earth is made of silicon and oxygen. And I'm going to ask you a really silly question. Okay, but think about it. Why can't you breathe the oxygen that is in the solid earth? Think about it. Do you know? What are you going to say? Yes, because it's chemically bonded with oxygen and silicon. It's not just oxygen anymore. Also, it's not a gas. Like, we have to breathe oxygen in a gaseous form. Okay, and obviously solid earth is not a form that we can breathe. Okay, very nice. Well done. Oceans are composed of oxygen, hydrogen, chlorine, and sodium. And that's if you really break that down and look at it, it makes sense. Ocean is made of salt water, right? So if you look up there, water is made of hydrogen and oxygen, and then salt, sodium chloride, it's NaCl, or chlorine and sodium. Okay? So oceans are made of oxygen and hydrogen, chlorine and sodium. And as long as you can remember that the ocean is made of salt water, and you know the chemical formula for salt, and you know the chemical formula for water, then you should be able to remember what the ocean is made of. Okay, the atmosphere. Nitrogen and oxygen. No surprise there. Both of them are gases. We know all living things need oxygen to live. And then lastly, you've got your living matter, which is made of carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. So anything that is living or once living is made up of those elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. If you're having problems seeing this and you want to move to the front, you can. Are there any of these that surprised you? Which one? Living matter? Well, think about when living matter, when it burns, it gives off that smell, stinky smell. Okay. Anyone else? Can we move forward? Okay. Let's talk about what a compound is. Okay, so you have a periodic table of elements sitting in front of you. A compound, so put the word compound to the left, is when you take two or more elements and chemically bond them together to make a new substance. So this is where you're going to the grocery store and you're mixing a bunch of stuff together and making something new. That's essentially what happens here. Okay, and so these elements are chemically bonded together to make a completely new substance. And compounds occur naturally in nature. Okay, so like nobody is out there making all the water for the oceans, right? Okay, H2O occurs naturally here on Earth. Okay, there are some compounds that can be made. Have you ever heard of a compounding pharmacy? One thing that pharmacists are really good at and they really enjoy doing is compounding their own medicines. Okay, but a lot of times you have to go to a special pharmacy that says, we compound, which means they will make a special compound of medicine for you. And they're usually more expensive. Okay, but your doctor can prescribe you a compound medicine. Okay, so compounds are when you take two or more elements and you chemically bond them together to make a new substance. The compound or the chemical formula for glucose is C6H12O6. The chemical formula for H2O is what? For water is what? Okay. The chemical formula for salt, does anybody know what that is? I wrote it up there. NaCl. Okay, sodium chloride. So here are some common compounds. You have rubbing alcohol, salt. Start thinking of some compounds that you know of. Basically, if it's not an element on the periodic table, it's a compound. You and I, we are compounds. We are made of one or more elements, chemically bonded together. Okay, let's talk about chemical formulas. Chemical formulas are a chemical formula, so put the word chemical formula to the left, is a symbol representation of a compound. So it's kind of like the recipe. Okay, so if you've ever wondered what water is made of, it's made of 2 hydrogens and 1 oxygen, H2O. Salt, talked about that one a minute ago, NaCl, it's called sodium chloride. Carbon dioxide, that's one you've seen before. CO2. Glucose, fancy name for sugar. C6H12O6. Rubbing alcohol, C2H5OH. Ammonium, NH3. Okay, just write down maybe 4 of those. Okay, you don't have to write them all down. But when we talk about chemical formulas, that is what we're talking about. Are you seeing all this academic vocabulary? Please make sure that you are getting on Quizlet and studying your vocabulary. Get in your science log, study your vocabulary. Can I move forward? Just about 60 more seconds. Okay. So tomorrow you're going to learn how to count atoms, which is actually really fun. So you need to know what an atom is. Okay, so an atom is the smallest particle of the element. And then you also need to know what a subscript is. So a subscript is like in a chemical formula, the number to the lower right of an element symbol, it indicates the number of atoms of that element. Okay, so in CO2, that tiny little 2 is your subscript. Okay, there is no subscript next to the C in CO2, which implies that there's 1. Okay, so 1 carbon, 2 oxygens in CO2 for a total of 3 atoms. Okay, and we're going to go over that tomorrow. So a subscript in a chemical formula is the number to the lower right of an element symbol indicating the number of atoms of that element. Okay, what does the subscript tell you in the chemical formula of water for hydrogen? How many hydrogens are there according to that subscript? 2. Okay, take a look at carbon dioxide. Okay, the subscript up there tells you how many atoms of oxygen are in CO2, how many atoms of oxygen are in CO2, according to that subscript. 2. Take a look at glucose, sugar. Count the atoms. How many atoms are there total in the chemical formula of glucose? Okay, if you said 24, you're correct. 12 plus 6 plus 6. Okay? Like I said, tomorrow we're going to do an activity. We are going to learn how to count atoms, and you're going to feel super smart. Feel real smart. Okay, can we move forward? Okay, so the last slide is more of an activity. Okay, I gave you a periodic table when you came in, and what we're going to do is we're going to color code our periodic table based on metals, metalloids, and nonmetals. Okay, so the first thing you need to do is create a key on your periodic table. Your metals will be blue. Remember we said the majority of elements on the periodic table are blue. Your metalloids will be green. And your nonmetals will be yellow. Okay, I highly encourage you to color your metalloids first because there are only 7 of them, and I would hate for you to accidentally color them blue. Okay, color your nonmetals next. Okay, because remember, hydrogen's a weird one. It's all by itself. It's over there to the left. It's yellow. It's a nonmetal. Okay, and then lastly, color your metals blue. Okay, please make sure that you are not using like a really dark marker. Okay, you're going to be using this periodic table during this unit. You're going to glue it into your science log. It's really important that you bring your science log every day because you are going to need this periodic table. Do not lose it. Okay, and we will glue the periodic table and your Cornell notes and your vocabulary into your science log. And that's all I have for you today. I hope you enjoyed learning about chemistry.